Okay, let us begin by understanding why we need to have such a course in which you are learning about computer applications and so on. Okay, what is the need of this course for civil engineers? Okay, I already talked about this. This is my introduction. You can see the email over here. If I don't reply to you on Teams, send me an email. Okay, I usually keep the Teams quiet. Okay, so if you're not getting a reply, send me by email. Okay, why do we need to have this course? Okay, so in this course we are trying to learn how we can apply the numerical analysis using computer softwares, right? Okay, this is the main theme of the course. So what are numerical methods? Numerical methods are techniques which are formulated or developed for mathematical problems. Okay, so in civil engineering or any type of engineering, we have mathematical problems, right? Okay, so these mathematical problems are solved through number of equations, right? The thing which you guys sometimes call as rules and formulas. Okay, so those rules and formulas and equations are part of numerical methods. Okay, so on those equations, then we perform some arithmetic operations, plus, minus, okay, taking the power and log and sine and cosine, and we try to come up with a solution for our problem, right? Okay, so since we are using numerical methods, in all these numerical methods, especially what we use at our level for the engineering professionals, so those numerical methods are not so easy as plus and minus. They are not 2 plus 2 and 2 into 5 and something like this. They involve very long calculations. This is what you guys complain about in the exam, right? You gave us one question. This one question is taking 3 hours, and the exam time is 2 hours. How we are supposed to finish it? Okay. So all these calculations, they require, or they have very tedious arithmetic calculations. They are not so simple as addition and subtraction. So how do we take care of them? Because if you are having problems during your exam solving one question, if the same problem comes in your office, they will not give you hours to solve this one problem. They want the results very fast, faster than us. Okay, so we use the help of computers, laptops, or whatever you call them. Okay, we use their help to solve these numerical methods, to go through these numerical methods. Okay, and obviously it increases our speed and accuracy, right? When you are solving through the calculator, a lot of time I have seen the students put all the values correctly, but their answer is 1 instead of 100, because they forgot to put one dot. It happens, right? So we are using computer applications to make sure that these sort of mistakes do not happen. Okay, and the problem is with calculators and with other manual calculation, you don't know where you made the mistake. You can make mistake in programming, right? You are the same person, you can make mistake in programming. Okay, but program is in front of you. You can correct it whenever you want. Okay, with other things it's not so easy. Okay, so we have a lot of calculations. They are very long, very complicated. So why should we do it manually if we have technology to help us? Okay, so this is why we have this course, and this is why I'm giving you that assignment, so that you guys eventually learn how to learn yourself. Okay, this is the theme of the assignment. Okay, what type of numerical methods we use in engineering or in science in general? These are some of them, and the good thing is you know all about them, right? You have used all of them. Roots of equations, you have used them, right? Quadratic equation, cubic equation, how we calculate the roots, we have done it manually. Systems of linear algebraic equations. So you know algebra, right? X equals to 3 into y plus z into something. So how to solve these equations? Okay, sine, cosine equations, you have already solved them, right? Optimization, Curve fitting, I will talk about them. There are some examples given for each one of them. Integration, you know, right? What is the opposite of integration? The opposite of integration. Dy by dx. What do we call it? This is integration, right? And what do we call this? So this is integration. And what is this? Derivative. Taking a derivative. Okay. Differential equations, I think there's a whole course about differential equations, right? People from maths teachers, both of them. Okay. So root of the equation is you find the value of the function where, you find the value of x where the function becomes 0. This is root of x. Okay, or root of an equation. You have a quadratic equation, you put the function equals to 0 and try to find out the value of x where the function becomes 0. Linear algebraic equations, something like this. So I'm trying to find out what is a11, a12 and a21 and a2 so on. Okay, solving these equations. So there are two equations. For each equation I have a line, okay, and the point where these lines intersect is my solution. Okay, we will talk about them in more details. Okay, but solving two equations to give you a common answer basically. I have equation 1, equation 2. I solve them so they merge at the same value. This is the root. Okay, optimization. So you are taking 3 courses, right? Summer, 3 courses. Okay, how much time would you give to each course if you have to study? Not talking about class. There are exams for all 3 courses in the same day. How much time you will give for each course for studying? 4 hours. Same time for all of them? No. What he is saying is called optimization. If he gives too less time, not enough. If he gives too much time, not enough for the other course, right? This is called optimization. Finding the right value, which is not too high and not too low. Okay, we do it in engineering all the time. We do it in your life all the time. While you are driving the car, you are doing optimization. If you are too fast, very dangerous. If you are too slow, again dangerous. Somebody will come from the back end, right? So optimization is finding the correct value, not too high, not too low. Okay, something which you can see here. Curve fitting, I give you number of values, 10 values. Okay, and I ask you, if I plot a line for these values, what it will look like. Will it be a linear? Will it be a straight line or a curve? Okay, got it? This is known as curve fitting. So you have values, but you don't know the equation. Simple thing is, you have values, there is no equation. This is called as curve fitting. Okay, so you can make your own equations. So one of you becomes a scientist, you make an equation, you give it to the students who will come after you, and you will take your revenge. Okay, integration. I told you integration is just right, but what does it mean for the data? When I take integration of something, what does it mean? I'm finding area under the curve. So x is what? X has an equation, right? X has an equation. For example, log of x. Okay, so I'm taking integration of log of x. Okay, and then you have to put limits, right? So I'm taking, for example, from 2 to 3. So I will take the integral and then I will put the limits, right? So I will get a value. For example, that value is 230. Now what is 230? Log of x. Log of x has this curve. Okay. When you take integration, you are finding area under the curve. Okay. You are finding what? Area under the curve. Okay. So I put a limit 2 to 3. So I am not finding the area for the whole curve. I am finding it under which values? 2 and 3. Okay. So have you taken a course in what? Surveying, right? So they do area calculations, right? Calculation of areas in surveying. Yeah, area under the curve, yes. Yeah. But I'm talking about calculation of area in civil engineering. Okay, so you know where to apply it. That's what I'm trying to say. Okay, so you can apply it in those surveying examples where you are trying to find out the area under the curve. You find the equation, you take the integral, you know how to take the integral from calculus. Yeah. Okay, so the value you will find is the area under that curve, okay, or the area of that figure. Okay, so ordinary differential equation, again, equation means you have a line or a curve, okay, and when you take the derivative, this is derivative, right? This is derivative, okay. So derivative gives you what? Slope. So x is changing because of y. Okay, let's say you take this and the value is 3. What does it mean? You said slope, right? So 3 means it's 3 upon 1. It's 3 upon 1. So what does it mean? X changes how many times? 3 times. When y changes? 1. So basically, ordinary differential equations tell you the effect of one variable upon the other. How much y affects x. Got it? And then you have partial differential equations, and partial differential equation we have we don't have one variable. So you are trying to find the effect of x on u and y on u. Got it? This is partial. So you take each. So there are a lot of variables in the equation, not one. Here it was only one. In partial, many. So you break them into parts. This is why we call it partial. Okay, so you break it into parts, partial. Okay. Okay, if you use non-computer methods, calculators are non-computer methods. Okay, you do it manually by hand, non-computer methods. Okay, so when you don't use computers, then you are either calculating the problem analytically, you are calculating the solution analytically, or an exact method. We will talk about that. Don't worry. Okay, there are 2 types of solutions to each equation. For every equation, there are 2 solutions possible: analytical and exact. Okay, so in non-computer methods, either you are using analytical or exact method. Okay, in some cases we use graphs. So you plot graphs, and from the graph you try to find out what is the, like you said, slope. If I give you a graph, you can find out the slope, right? Measure x and y. Easy, right? So you can use graphs, okay? Or you can use calculators and scales and protectors and so on to find out what I did or what I usually do in traffic engineering course. You have to go to a highway and you have to collect some data. Okay, so what do? They need dimensions of the highway. Now you know about surveying, right? So they can go and do a survey of the highway. But what's the problem? If they go and they are trying to do a survey and there are a bunch of students like you. What do you mean? Yeah. Okay. Nobody will stop for you. So I may start the course with 40 students and then I may end with 4. Rest of them are in the newspapers. Who was killed on which highway? So we cannot do a survey of the highway by ourselves, right? So what do? They go to Google Map or Google Earth and they take a print and try to measure everything from. So this is what they are saying. Instead of using equations, measure it. Okay. But if you have an equation, it's much easier, right? It's much easier. Okay. So we already discussed. You are becoming civil engineers, right? Civil engineering is a offshoot of science. Okay. So we involve a lot of quantitative analysis, lot of numbers which you have to analyze and you have to calculate and so on. People are expecting numbers from you. You will get numbers and people are expecting you will give them numbers. Okay. So and those analysis about a physical phenomena. Give me one example. Numbers about a physical phenomena. Give me one example. Let's say you are Newtons, then. If you are Newton, then. Or if you are an Einstein, then. Which physical phenomena we are talking about? The Newton gave which physical phenomenon? Gravity, right? Gravity is a physical phenomena, right? And what about Einstein? Electricity. Okay. So the volts and these things. Okay. Basically the transfer of current, right? So what did they give us? A number. They did some calculations, some quantitative analysis. What was the physical phenomena? Gravity, weight, or movement of atoms and molecules and so on. And what did they give us? They gave us, the value of gravitational force, right? You know that, huh? You know E equals to mc square, right? Okay. So those were what? The result of the analysis which they done for the physical phenomena which they observed. Okay, we are going to do this. We are using it and we have to do it ourselves sometimes. Okay. So to do that, we need a very sophisticated and complicated mathematical calculations. Okay. So again, we use computer softwares and packages and programs to help us do all these calculations. There are some specialized packages which help you with certain problems. I gave you a list of problems, right? Taking a root of an equation, solving algebraic equation, area under the curve, partial differentiation. There are software packages available which can help you do only one type of calculation. Like they have given us one example. Okay, so LPAC is a package which only helps you with this. So this is a specific type of calculus problem, mathematical problem. So we have a package which can only do this. It doesn't do anything else. Okay, so we have packages like this, very easy to use, but their use is very limited. You can only do one thing, nothing else. And then there are some general purpose software by which you can do anything basically, all types of calculations or all calculations which I just showed you. Okay, for example, we have Mathematica. Okay, this is the name of the company. Okay, don't worry about it. Mathematica. We have Maple. Okay, we have MATLAB. Okay, so these are what? General purpose. General purpose means what? All those calculations I talked about, you can do it in these softwares. Okay, in all of them. And you have a new equation which was not there 2 years ago. You can still solve it. You can still program it yourself. Okay, so you are not depending upon what the program can do. Program is giving you options. Okay, so this is why we call them general purpose. Okay, but we will only do one of them. Okay, and then we have IDL. What is IDL? Interface Development Library. Okay, IDL stands for Interface Development Library. Okay, now so you know when they ask for, like, you have submitted assignments online, right? So you use what? Which format? No, the file. The file is in which format? And I'm talking about general, other courses. When you submit assignment online, PDF, right? PDF. Okay. So PDF, you can convert any file to PDF, right? And then people can extract information from PDF as well. They can reconvert it as well. So PDF file is what? It's an interface development library. So everybody has PDF, right? You send me a file, I may tell you, okay, this file is in, you use Mathematica to make this file. I don't have Mathematica. What should I do? Then you convert it to an ideal format. Okay, something which is common. Okay, so if you go to any of these softwares, including MATLAB, including Excel, including Word, you will always find the option to convert that file into PDF. Okay, I just had a problem this last semester. My students, one of my students, PhD students, he did some calculation using SPSS. This is software, okay, for doing his statistics. So he did some calculations. The reviewer said you did not include the calculations in your report. So he said I will include it. He went back and he was trying to get the values from Statistica. From SPSS. The software did not allow. The report is in what? Word. He is trying to get the table out of the software to put it in the Word file. Not allowed. So what did he do? He converted the file into PDF. And then he attached the PDF. So he converted the Word file to PDF and the software file to PDF. And then he joined them. You get the idea? Okay. So you use AutoCAD, right? You have used AutoCAD. So Excel is like an IDL for all engineering softwares. Excel, all engineering software, either they give you the output which you can open in Excel, or they can take the input from an Excel format. You know, Excel has many formats, not just the XLS. Excel has many formats. Okay, so one of these formats can be taken as an input by many softwares, and those softwares give you an output which you can open in Excel directly, including MATLAB and so on. Okay, so Excel is like an IDL. Okay, just some introduction about the softwares which I already mentioned. It's an all-purpose software. What is included? You can do symbolic and numerical calculation. Symbolic meaning in terms of x and y and a and b. Numerical calculation is what? 2 plus 3 equals what? 5. This is numeric. X square plus 2x equals something. This is symbolic. Get the idea? Okay. All-purpose graphics. So you can generate a lot of graphs and so on. Okay, pictures and graphs and so on. And it's a powerful programming language, so you can develop your own program. Okay. It has a notebook interface. Okay, so you can document your work. Okay, so there's a program. Sometimes you look at the program, you don't know what happened. There's a mistake in the program, I don't know where is the mistake. Okay, so they give you a notebook interface where you can write. So command number 10 is supposed to calculate sine of something. But I made a mistake in the program, so I don't know what happened. But you go to the notebook, you know what is supposed to happen. Okay, so in the notebook you write all the steps. Okay, it's a functional programming language. Excel is also functional, most of it. Functional programming language means what? You know, in calculus you may have solved, you may have done solution for these equations, right? Solution for these equations and these equations. Okay, so you do them manually. Okay, but if you use any software, you just write derivative of x. So derivative is what? It's already a function in the program. The program knows what to do. Okay, so most of the things which you have studied in calculus, they have a function. They made you do it manually, right? So you build your muscles. But so you may have calculated sine of x manually. You may have done derivative of x manually, integral of x manually. But these things have a function. Okay. So Mathematica is a functional programming language. You go there, you write sine of x, derivative of x, integral of x, and the program will give you the solution. Okay. And other thing is, if you develop your own equation, you can save it as a function. So you tell me, Dr. Uneb, you can find the value using this function. I type the function. I will not write the whole program. I just type your function, and the program will give me the whole. It will do the whole calculation. This is what they mean by functional programming language. Okay. Drawbacks. It requires more expertise. Okay, like according to them. Okay, I'm not saying it. Maybe you open this program and you find it very easy. According to them, they say that for using Mathematica, you need more time. This is what they're saying. Okay, then we have Maple. Okay, again, it can do analytical solutions as well as mathematical solutions. It does most of the things what we have discussed earlier. Okay, you can do the programming and graphics and so on. Okay, with similar high quality, so it is very similar to Mathematica. Okay, but it is a procedural language. So for many things you will not find the function. You have to do the programming yourself. You have to do the programming yourself. So you don't write sine of x. I'm just giving you a very basic example which you know. Sine of x is everywhere. No program will ask you to do the calculation for sine of x. Okay, but I'm just giving you a very basic example, the thing which you already know. Okay, so let's say sine of x. Okay, so if you go to Mathematica, you write sine of x, it will give you the value. You come here, you have to write the solution for sine of x, the full solution, then it will give you the value. Okay, so and there are some old languages, Fortran, I have used it. Nobody uses it now. But C, I think you mentioned, right? C++. Yes, sir. So these are procedural languages. Less functions, but more options for programming. Now you see the difference here? Let me. Okay. So the drawback for Maple is the worksheet which you are using for typing your program is not so helpful as mathematical. Okay, it's not so easier to understand as mathematical. Okay, but it is less expensive. Less expensive, it means time. Less expensive meaning in terms of time. It will take less time. Okay, now can you see the problem here? Can you see the issue here? With Mathematica, we said what? It has function for everything, but it takes more time to learn. In Maple, we said what? Less time, but it's a procedural language, right? You have to write program for everything. That program has functions. I need more time to learn it. This program doesn't have functions. I need less time to learn it. How is this possible? More functions means easier, right? I say do sin of x. It already knows what is sin of x. It can do it. So why do I need more time? I need more time to learn those functions. Get my point? When the language is very basic, it takes less time. Okay? For example, let me give an example. Somebody asks you, learn ABCD. A 4-year kid can do it in one day. You know that. A 4-year kid can learn from A to Z in one day. Ask the same kid after 2 years, not the same age, but after 4 years. That's it. So he or she was 4 years old when he knew A to Z. Is there any new alphabet? No. Ask the same kid after 4 years, make sentences. It's still difficult. He knows ABC, right? It's still difficult. Why? Because sentences have to be in a specific format. You have to learn about nouns and pronouns and prepositions and verbs and different tenses and so on. So it becomes more difficult. Okay? So this is the difference between procedural and functional. Procedural is what? Learn ABC and do whatever you want. Huh? Put A and B and C together, put A and C and D together, no problem. It is procedural. Okay, so less things to remember. But when I tell you about functional, functional is like making a sentence. So you know the whole grammar. You have to know the whole grammar. Okay, got it? Okay, so if I write sin of x, okay, maybe the program doesn't accept S capital. It's a functional language. It doesn't accept S capital. So I need to learn these things, right? Which things can be used capital, which things can be used small letter, where should I put the bracket, where should I put the comma, and so on. So it takes more time. It has function for everything, but to learn every function, I need more time. Okay, so this is the case. Okay, then comes MATLAB. What we will do here? Okay, it combines efficient computation. Okay, so it can do computations very fast. Visualization. For every computation, you can see the results. You can develop graphs and tables and so on. Okay, programming for linear algebraic technical work. Okay, so you have a set of equations. There is no function for it. You can program yourself, no problem. Okay, and other mathematical areas. So programming is open for anything which you want. Okay, and it is most widely used language in engineering schools. So it's not only UOB. If you are doing engineering somewhere else, they will still be teaching you MATLAB. Okay, like I said, in Pakistan, we were taught MATLAB. Okay, we are not good example. KFPM, MATLAB. There are some other universities that are using MATLAB. So it's very common for engineering students. Okay. but it doesn't support analytical or symbolic mathematics. Okay, we have already talked about it, and now we will talk more in detail. Okay, what are models or equations? Models means equations. This is a model. Right. So every equation is a model. Okay. You know that, right? What is it? A model. Okay. Force equals mass into acceleration. It's a model. Does this happen in real world? It does, right? Huh? If I throw something, force equals mass into acceleration. Okay. The force by which it will hit you equals what? Mass into acceleration. You go online and you will find videos. Now they are very common. They will show you a car hitting a pole at 10 miles per hour, 20 miles per hour, 30 miles per hour. That happens. You are coming very fast, you hit someone, more force, right? So this equation is what? An abstract or something which is happening physically. Okay, an abstract for something which is happening physically. This is the aim of having a model or an equation. An equation or model does what? Something which is happening already in the world. It tells you this is how it is happening. So force is increasing because of mass and because of acceleration. Okay, and it can be any type of phenomena. Physical is more relevant to us. We are more concerned about what is happening physically. Okay, but there are equations for social phenomena. You know who uses these equations? Equations about social phenomena. Who uses them? You know? Don't know? It's in your phones. Okay. One of my friends, she lost her account on social media. So she made a new account. Okay. When she opened the new account, all the pages which she liked earlier, suggestions were coming from her. Then she told me, and I said, okay, fine. Send me an invitation. I will, get friends again and so on. So when I make friends with her again, what happens? The suggestions start coming, right? Make this your friend. Make this your friend. What is this? A model of social phenomena. Economical phenomena, very easy. You see, have you heard about Vision 2030 for Bahrain? Vision 2030. Okay. And there's a Vision 2050 for Saudi Arabia. So every country has their own vision, right? So in their vision, they say after 20 years, our growth rate will be this much. How? They use economical models. Okay. So every field has their own models. You guys will also have a course of engineering economics, right? You will see the economic models here. Okay, why do we need models? To understand complex systems and phenomena. Okay, so if you don't have an equation, then you don't know how to calculate the forces, right? I'm going to design this structure. I don't have the equations to find out the forces. I cannot design the structure, right? Same thing with the roads, same thing with the water pipelines and so on. So I need models to do the design. Otherwise, I don't know how the whole structure will fail. I don't know why. Okay. Okay. A model only captures aspects of the original system. It does not take everything into account. The equation is much simpler than real world. Equation is much simpler than real world. Okay, I showed you a very simple equation, yeah, right? But they are very complicated equations. Okay, even those complicated equations only take a part of the real world. They only show you a part of the real world. Okay, so that because we are only taking a part of the real world, because we are not talking about everything. We are only talking about what is concerned to us. Okay, so if you are designing this building, do you care about my clothes? Huh? You don't care, right? If I or you don't care about my income, right? Okay, so that's why equations are simpler, because I only care about what? My weight, which is too much, by the way. So equations are simpler than the real world. Why? Because I'm only interested in part of the real world. I'm not interested in everything. Okay, according to my field. Okay, so for example, the study of lift-off properties of wing in a wind tunnel. Okay, so a wind tunnel is it's a corridor, like how do I say it? When you go along the beach. So if you are moving along the beach, the wind is usually stronger, right? Along the beach, the wind is usually stronger. Okay, so this part is known as a wind tunnel. The part of the earth where the wind velocity is usually higher. So if you have to install, a windmill, these fans which generate electricity, they have this in one of the buildings, right? In Manama, I think. Okay, so if I want to build the wind tunnel, if I want to put a wind turbine, where will I put it? A wind tunnel. Okay, so I'm only interested in what? The wind velocity. I'm not interested in how much sunshine it has. Okay, or the width or the length and so on. Okay, I'm only interested in one thing. Okay, so computer simulations. What are computer simulations? So normally in science and engineering, either we use theoretical studies. Okay, so somebody says, if I do this, this will happen, according to his observation. This is theoretical. We use experimental studies. Okay, so you go, you take a sample, you test it in the laboratory. This is what? Experimental. And what is simulation? Computer simulation. So you go and you prepare a computer program which will show you what will happen in real life without going in the real life. A computer simulation will tell you what will happen in the real life without going in the real life. Okay, so computer simulation is made up of what? Models and equations. Okay, so in this class we are only dealing with what? Computer models and physical systems. Civil engineering, physical systems. And we are not talking about experimental work here or theoretical studies here. Okay, mathematical models, I've already talked about it. Formulation or equation, which gives you the physical system in the form of equation. Okay, so in a model, we have four things. Every equation has four things: dependent variable, independent variable, parameters, and forcing functions. Okay, what do we mean by that? So this is what now the left hand side, right? So the variable on the left hand side of the equal sign is what? Dependent. Variable on the right hand side, independent. Okay. Every independent variable is multiplied by a parameter. Okay. And then these things are subjected to a forcing function. Okay, I think I have an example. Okay, so what is a dependent variable? the variable which gives you the state of the system. Okay, for example, in this case, how much force is generated in the system. Okay, how much force is generated in the system. So this is what? Dependent. The outcome, the result. Okay, so dependent is what? The outcome or the result of the system. Okay, independent is what? It can include dimensions of the system. So I will have a force of 100 when m equals to something and a equals to something, right? So m and a is what? Dimensions of the system, not physical dimensions. They can be any type of dimension. Like I said, dimension can be time as well, after 2 seconds, after 3 seconds. Okay, so independent variables are dimensions. So dependent variable will give you this result when dimensions of the system are equal to this, and dimensions are independent variable. So force equal to this much when dimension of m is equal to this and dimension of a equals to this. Okay, parameters, they have given a very common term here, very easy to understand, constant. So every equation has a constant, right? So that constant is known as what? Parameter. Okay, if I'm using this equation, can you tell me the constant here? What is the constant? M. M is a constant. Okay, so M is a parameter. Okay, forcing function, how do these parameter and independent variables, they should combine. So how am I combining here? I'm multiplying. You can generate another equation, m upon a. So forcing function will be division. This equation, forcing function is what? Log. Okay, so forcing function is how independent variables and parameters are combined. Okay. Okay, so we have conservation laws. Okay, for example, you know, law of conservation of mass, law of conservation of energy, and so on. Okay, so these laws of conservation provide you the basis of your model. Okay, what do you mean by this? This equals this total, right? Total. This equals this. This is what? Law of conservation of what? Which law are you talking about? It can be more than one. Huh? This is conservation of mass, conservation of momentum, conservation of charge, conservation of energy. So mass, momentum, charge, energy. Which one? Momentum, right? Okay. So the acceleration is converted. Acceleration is mass is converted to force, total, right? All of it. This is the laws of conservation. Input equals output. Law of conservation of anything. Okay, so all equations have a right hand side and a left hand side. Input and output. Okay, law of conservation. Okay. So some models can be given as functions or differential equations. Okay, and you can solve them using analytical methods or numerical methods. Okay. Once you have the equation, this one or this one, you can solve it using analytical method or numerical method. What do we mean by this? Analytical method is more exact. Okay, it gives you exact solutions. not always feasible because it will require a lot of calculations. Okay, I want to know the exact value of the output. So my calculations will be more complicated. I will have to encounter more variables. Okay, solution will be longer because I need an exact answer. Okay, got it? Let me give an example. If I ask, or somebody asks me, how many students will I have in the class today? Okay, I would say 7, 8, anything between 7 or 6 and 9. This is what? Approximate, right? Somebody asks me, give me the exact number. I have to come to the class. I have to count each and every one of them, right? This is analytical. So to get the exact answer, I need more effort. Simple. To get an A, you need more effort. Okay. Numerical is what? Approximate. The first example I gave you. Anything between 6, okay, between 6 and 9, I don't know. I just look online, how many students are there? 9, okay. Maybe 50% of them will attend. 6 and 9, no problem. Okay. So this is called as numerical. Easier. Okay. So how much time you will put to solve a numerical method depends upon what? How much accuracy you need. If you need 100% accuracy, it becomes what? Analytical, right? Exact. If somebody says I need 100% accurate answer, it becomes what? Analytical. Then I need more effort. Somebody says 90% is enough for me, less effort. Got it? Huh? Okay. An example, somebody has done it here. Bungee jumping. No? No? No one? Try it. Okay. Fun. Okay. So so they will they will tie your leg and they will push you over the mountain or hill or something, and then you are hanging in the air, and that's how you get the fun out of it. Okay, so this equation gives you the change in velocity of this guy who is hanging in the air. Imagine some guy is hanging in the air and we are driving our equations. Okay, this is how cruel we are. Okay, so this equation gives you the change in velocity of this guy who is hanging in the air. Okay, so the change in velocity is affected by gravitational force, okay, and the drag force of the the rope. Okay, so there are two forces acting. Gravity acts which direction? Downward, and the drag is taking him up. Okay, so when those forces are balanced, what happens? Yeah, so this guy will stop. Then he will realize, oh, now I'm in danger. Somebody pull me up. Right? Until now he was having fun. When we reach equilibrium, now he's in danger. Okay? Here's how things are. So dependent variable, what I'm calculating? Velocity. Depending upon what? Time. So velocity dependent. Time independent. Okay? Parameters, mass, coefficient of drag, and so on. And forcing function, the gravitational force. Okay? So the analytical solution is you can solve this equation, okay, for velocity, and you can have a graph like this. This is analytical, okay. So you solve it, you solve the whole equation, calculate the velocity at each and every point, and plot a graph like this. This is called as analytical solution. Okay. Numerical solution is that you prepare an approximate solution between two values of time. 1 second, 2 seconds. 2 seconds, 3 seconds. Between an interval of time, you calculate the numerical solution, okay, and instead of getting a smooth graph, you will get something like a series of lines. Between 2 seconds and 3 seconds, one line. Between 3 and 4, another line, and so on. Okay, so this is known as the numerical solution. So if I apply the numerical method for 2 second interval, you will get a line like this. Okay, the analytical solution, the exact solution gave me what? A curve, right? Can you see the difference between them? The curve is here and my line is here. Now you see here, no problem, same. Here, no problem, same. Here, big problem. Okay, so this is why in some cases we can use numerical methods, in some cases we may not. For example, if somebody is doing it only for this time, no problem, same, right? Analytical, numerical, same. Somebody is doing it for this value, last value, again numerical, analytical, same, no problem. Somebody is doing it for each and every step. The error will go from 0 to 100. Okay, so big problem. Okay, now how can I make them closer? I did it for an interval of 2 seconds, right? Instead of doing it for 2 seconds, do it for 1 second. Calculate value for 1 second. You want to make it more exact? Do it for 0.5 seconds. Want to make it more exact? Do it for what? Less than 0.5, huh? Okay. But if you keep on decreasing the time, what are you doing? You will calculate more value, right? Your work will increase. Okay. So this is the trade-off between numerical solution